Hi, welcome to the Calculus 2 lecture series, and we are still on our second lecture, how to find the volumes. And this is the part 2, the second video for the disk and the washer methods here. All right, so let's for the first video we discussed what is the disk method and what is the washer methods, right? And we are talking about the region like rotating around the x-axis and y-axis. For this video, we will continue to find the volume, but instead of rotating along the x-axis or y-axis, we'll take a look. How about if I'm rotating into a different lines here? Like how about if I'm rotating to x equal to 1 and y or the y equal to -2? And how about if not the x-axis or y-axis anymore? Then how do we do it? Okay. All right, so let's go back to our lecture note. Let's continue here. Okay, so we stopped at example 3 for our first video, and we talk about the disk method and the washer methods here. Like you see here, we highlight a few things we did in the first video. Okay, so now when we talk about rotating about a lines here, right? So what do we need to do here? So this is very similar like the washer methods here. And so let me try to, so the rotating about the lines here, right? So basically you need to know is let's try to find the examples here. All right, so this will be the easy examples here. Okay, so and I have my function, so let's take here. So if this is my function, this is my simple functions here from this area. So okay, so let me color that. So this is the region I am rotating, but instead of the rotating to the x-axis, all right, so I'm going to rotating here. I'm rotating to y equal to the -2. So let's see here, right? So this is -2 here. So that means I am going to basically what here, I'm shifting my x-axis to this new line. So for example, this is y equal to -2 lines here. So I'm going to rotate in here. So take a look here from here. This is so for you try to do this type of problem, it's better you always graph it, all right? So take a look, you are you shift the x-axis to here, all right? So now in here, let's take a look how, what is rotating looks like. So this point, right? So this point, because 2 units from the new rotating axis here. So that means this point, boom, rotating to where? To here. Am I right? And then this point go boom, rotating to where? Go back to here. Right, so this will be the rotating part. So that's why I always use the dot line to demonstrate that. All right, okay, so now let's take a look here, right? So this is the after rotating, so I'm still rotating, worry about the solid for the green area and the yellow area. Okay, so now let's take a look. This is my rotating, right? So if you put a kind of draw little circles here, can help you to visualize the rotating part. So that's why I always said I would like to kind of make sure you draw pictures, right? Okay, so now let's take a look here. So now I'm still doing the same way, the cuttings, right? So if you cutting here, you cut a slice here, right? So you cut a slice. So this is back to what? This is back to what is very similar like we did for the washer methods here. So I'm looking for the volume for this rotating by the yellow area, right? So I have this boom, 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 boom. So I have this big disk, the red one. And then the same times I have what? I have the, my other, I have the another ones here, right? So this is the red ones here, and then I have a small ones here. So that's why it become like the Washmans here, right? So the areas here for this disk will just be what? It's pi to the what? We have the outer radius square minus pi to the inner radius square, right? All right. Okay, so then you can just integrate that depending on what is the regions of the x values here. Okay, so now let's take a look. Let's take a look at some example that will make the things a little bit easier. Okay, so the region R enclosed by the curve y equal to x, y equal to the x squared, rotating along the line y equal to 2. So find the volume of the resulting solid here, all right? So the first here, let's do a quick graph here, all right? So now I'm going to make the graph a little bit bigger. So y equal to x is what? Y equal to x is these lines, right? And y equal to x squared is what? Is this quadratic, right? So we are looking for the area enclosed by these two. That means we are looking for this area, correct? And so I'm going to enlarge this area so we can see better here. All right, so I'm going to put this is a little bit larger scale. Okay, so here this is 1, 2, 3, 4. 1, 2, 3, 4. So this areas here is, the intersected ones, right? So it's 1, 1 still, even I enlarged it, still it's not too big. Yeah, all right, so this is the, let me try to here, okay, so, okay, and then I have this, the curve here, okay. All right, so I'm highlight this one. So this is the area I'm going to rotating here. All right. Okay, so now, okay, so now, okay, so here is be careful here. We are rotating this area along the y equal to 2. Y equal to 2 is this line. So basically right now, I am shifting my x-axis up, right? So this is y equal to 2. Okay, so like I said, be very careful, right? So let's try to rotate in here. So let's do a graph and then we know which one to minus which. So this, okay, so for this one's here, so this intersection point, right, is 2 units away from my new rotating line. So that means, boom, this one, right? So this one going to rotate into where? Rotate into here. Am I right? All right. Okay, now for this point here, this point is 1, 1. So it's kind of like 1 units to the new axis line. So what is this point going to rotate into? This point going to rotate into here. Right? Okay, and now my curve, so this one going to boom bend here. All right. Okay, so now this is my new rotations here. All right, so here. So this will be, let me see here. Okay, so here, let's see here. Okay, so this is my area, right? So my area going to be, the close to the, so those will be the volume generated. The yellow will be the volume generated by the, these regions, right? Okay, so after we do that, and then the problem getting easier. So we say, okay, now let me try to cut a slice, right? So you cut a slice here. So you say, okay, this is my slice, right? So this is my disc. I cut this disc, right? So when you cut this disc, so because I'm only worried about the volume generated by the yellow area. So in here, so what is my radius here? My radius for the bigger one is all the way from here to what? To this red one, right? Oh, from here, let's do here, from here to here, right? So from here to this red curve. This red curve is what curve? Y equal to what? X squared, correct? Okay, so now the volume, so the volume will just be from the 0 to 1. Okay, so this blue one, right? So this blue one is the radius is from here to y equal to the x squared. So what is this radius will be? So this radius will be, let me color code that. All right, so this radius will be the total distance, right? So will be 2 minus x squared to the square, right? Pi r squared. So the radius for the blue one will be 2 minus x squared, right? So this is the radius number 1. So it's 2 minus x squared, so pi r squared, then you square that. Okay, so now let me choose another color. Okay, the purple one. Let me choose the purple color here. All right, so now in here, you need to minus this one out, right? So you need to minus, so this is kind of like we talk about is, right? So it's a washer, right? So what is the radius for this purple one? Is from this one, y equal to 2 to the green one. So the green one is y equal to x, right? So now let's say here, so the purple is radius number 2. The radius number 2 is 2 minus x. Cool. Okay, so now this will be minus pi r squared. So what is the r here is 2 minus x squared. And then the whole thing's right. The whole thing you do a dx here. So good. So, when you do the rotation about the line, the best way is try to graph. So you will know where is your outer radius, where is your inner radius, right? Then for this integration, so basically you can just FOIL it, all right? So these ones here, you can put the pi out here. Then you can FOIL this one will be 4 minus 4x squared plus x fourths minus 4 minus 4x plus x squared, right? dx. Then this will be just a very simple, maybe a little tedious, but it's a very simple integration. And so if you carry out, and this will be the 8 pi over 15. Okay, so it's the same things here. So remember here, right? And now the things that I want to highlight a little bit, because you are shifting to the y equal to 2. So basically, y equal to 2, that means you are shifting the x-axis. So you are still integrating by what? By x here, right? So that's why it's dx, because y equal to 2. So you are shifting around the x-axis. So it's very similar. You still, the integrate by the x-axis. So that's why you integrate respect to the variable of x here. All right, now let's take a look at the other ones here. All right, so now this regions here, let's say I'm going to rotating this region, y equal to, so it's the same regions, right? So y equal to x and y equal to the x squared. So it's the same region, so it's the same here, but now I'm rotating along the y-axis here. So let's try to put it into a big picture. So what do we have here, right? So let me enlarge that. Okay, so this is 1, 2. All right, so this is 1, 2. All right, so we know that region a while ago we kind of did that. So this is the, so it will be the line here, and then we're going to have a curve here, right? Okay, so from the previous examples here, then the area we are curious we want to do is this one. Yeah. So far so good. All right. So this is the areas, right? So now we are going to rotating along the x equal to -1. Okay. So that means I'm shifting which axis here? I'm shifting y-axis, right? So this is the new axis here, x equal to -1. Remember? Okay, so now let's see, how do I shift the point? The same ones here. So this is the point. So let's first start here, right? So the now is 1 unit away from the new axis here. So this point, boom, go where? This point, boom, go over to here. Am I right? Okay, so then this point here, this point is 2 units away from the new origin. So what is this point is rotating to? Boom, is rotating to here. Am I right? All right, and then this little curve here going to go down here, right? All right, so here, this is my new. Okay, so this is my line. The area should be the same, but look a little bit bigger. So, all right, maybe we do a better job of graphing here. So here, this is 1. So here, and here, this is my little curve here. Okay, so this is the area generate. So this is the area I'm rotating. Okay, so now the next thing's here. Okay, so you are rotating here, right? So let's try to do that. Okay, so this is what you are rotating. Whoa. All right. Okay, so now let's cut a slice, right? Like I said, always do a picture. So cutting a slice. All right, remember the volume we care is generated by those yellow regions, right? So the first ones here, I have this, so my out radius R1. Let's take a look at what is the radius R1. R1 is from here all the way to this function. And we know this function is y equal to the x squared, and this function is y equal to the x, right? Remember my color coding here? Okay, so now let's take a look at what is the radius for my outer here. So because you shift to -1 here, right? So this is -1. So the total distance will be 1 plus whatever to the function. Correct? And because right now we are shifting to the x equal to 1, I am still what? I'm rotating to the y-axis. So I need to change the functions, right? So this one is y equal to x. I need to change it to, because I'm looking for the distance of x. So x is equal to the square root of the y. So what is my radius here? Will be 1 plus square root of the y. Am I right? All right, so this is the big outer radius. Then we said we need to minus out this. So because this is wash methods here, we need to wash to minus out this little circle. So what is the radius of a purple one? Is from here to here, touch here, right? So my radius number 2 is here because I shift here 1. So then this is y equal to x will be 1 plus what? 1 plus y. So I'm still integrating respect to what? To the y's, right? So now after you find those radius, then the integration will be pretty simple. So it's v is equal to, so what is the y value? Y is from 0 to 1, right? So I'm looking for the y. So pi r, so what is the outer array? The outer array will be, the outer radius will be 1 plus the square root of the y to the square. All right. Then minus the inner array, so it's a pi. What is here? 1 plus y to the square, right? Pi r square minus pi r square. Then take the integration for what? Respect to the y's here, remember? So it's a dy because the x minus x to the -1, this x is really is just what? It's just the shift to the y-axis. So I'm integrating respect to y. Then this one is become very straightforward integration. So basically you take the constants out and then you FOIL that. So this is 1 plus 2 square roots of the y plus y, then minus 1 plus 2y plus y squares, right? So you FOIL it out and then you combined. And in here, I think everybody know how to do that. And the answers here is pretty beautiful. It's a pi over 2 will be the volume generated by rotating these regions here. All right, so that will be this video. So it's a pretty simple concept, right? So when you're rotating about the lines here, it is better try to graph it. So like I say, if it's rotating about a line like y equal to some constancy, you are just shifting the x-axis here. And if you are rotating to the line to the x equal to some values here, you are just what? You are just shifting what? Shifting the y-axis, correct? So you are still integrating to y, all right? So that's it. And so like I say, if you do a graph, probably will be very helpful to visualize. You need to plus or minus the values here. So when you remember, when you integrate respect to the y, you need to change the x to a function of the y. If you are integrating to the x, then you change y equal to a function of the x. Yeah. All right. Okay, that's it. And I hope you enjoyed this lecture, how to find the volume by using the disk and the washer method by rotating the region around a certain line. So the first video we talk about around the x-axis, y-axis. Then this second video we talk about if you shift the axis. Now how do we do that? All right, that's it. And our next one, we're still going to find the volume, but we're going to introduce a new method. Instead of the disk and the washer, we're going to talk about the shell methods here. All right, nice to talk to you. Have a good day. Okay, bye-bye.